double check every time now because
Hmm.
you press go live and you think it's gone live and it hasn't.
Yeah.
But to answer your previous question, now we are live. Today will be we will be releasing episode 40 about breaking the internet speed record.
Cool.
But what we're doing now will be, in the late 50s.
Okay. Yeah.
Yeah.
I've got some cool articles that I found yesterday that we can talk about in future episodes. So there's some cool stuff coming up.
Fantastic. And thanks for those who are joining us live. We appreciate it. If you have any questions for what we're talking about, just throw them in the chat or the comment wherever you are on LinkedIn or Twitter, and we'll see them and be able to respond. So we got a lot going on this month, but we might as well jump right into these articles, and then we can talk about what's going on at the end. What do you think?
Absolutely.
So I normally do the intro, but we're already into it, and we're a few minutes late. So this first article talks about Ferrari patents their new hydrogen-powered engine.
Yes. More solidification that hydrogen is the future. Love it. Love it. Love that Ferrari's behind it. Hopefully, my favorite car maker, Koenigsegg, will get behind it. That guy, Christian von Koenigsegg, just on a side note, is the things that he's invented, the things that he's come up with, the fastest revving engine, one of the best EV engines out there, most efficient and most powerful. I think 700 horsepower in this little thing. But we're talking hydrogen. So hopefully more come on board. I know. Oh, one of the things we'll talk about next time in a future episode is Porsche has developed a new engine as well. It's not fully hydrogen, but it's something in between. So it's really cool. But let's dive into this one. This is from a patent that they recently filed for hydrogen-powered ICE, which stands for internal combustion engine, which is showing that their interest in hydrogen fuel as a way to reduce emissions from their performance cars. So the thing that if just as a side note too, that if you're seeing or if you're following the news, a lot of car makers are pulling back on their EV promises and as far as manufacturing promises and production things. So who knows what that means, but this is great for hydrogen. So the key distinction from a hydrogen fuel cell vehicle is that Ferrari's concept involves burning hydrogen in an internal combustion engine instead of gasoline. So obviously it would eliminate carbon dioxide emissions and produce water vapor and trace pollutants. I think it shows that hydrogen combustion has future potential even as electrification grows. Hydrogen fuel would allow Ferrari to maintain the distinctive feel of combustion power while reducing environmental impact. However, as we talk every time when we bring up hydrogen, there's infrastructure challenges. Limited hydrogen refueling stations have obviously frustrated fuel cell car owners already. And then manufacturing hydrogen renewably is also it's critical for true emissions reductions. But regardless of that, it's still better than the EV currently. So the other thing too is weight and size of hydrogen fuel cell systems that are obstacles. But Ferrari admits that their hydrogen car would be larger than gas-powered equivalents. So the other thing is quick refueling could be counterbalanced by reduced energy density compared to gasoline. So overall, the patent highlights that hydrogen combustion remains of interest to sports car brands eyeing low carbon alternatives to preserve their gasoline powered lineage. It offers promise, but obviously needs more work. The patent itself does contain some technical details that give clues into Ferrari's thinking. For example, they propose a high pressure direct injection system for the hydrogen fuel, as well as discuss modifications needed to prevent backfire into the intake and different things like that. So really cool. Love hydrogen. Awesome.
Yeah, the car looks great. I thought I saw something where it was 650 horsepower. I'm not sure if that's what's in here, but what they're doing is amazing with the internal combustion engine. Now, one of the things that maybe we should explain to people is the difference between an internal combustion hydrogen engine and a fuel cell based car.
Yes.
And Do you want to do that, or do you want me to?
No, go ahead. No, go. Yeah, no. I talk too much during these, so yeah, you go ahead.
So at a layman's level, the fuel cell based vehicle is an electric vehicle powered by a hydrogen fuel cell, meaning it has an electric motor, and it is considered zero emissions. While the internal combustion engine is like a regular engine, except it uses hydrogen instead of gas, and it produces water, but there's also some emissions because the engine heats up to a certain level and there's oils involved that come off it, which is why I'm surprised they say this is zero emission. But those are the difference between the two, is one is an electric motor and one is an actual internal combustion engine. That's basically the big difference.
Yeah.
So I was surprised when they said zero emissions for this, but you know, it's a fraction of what a gasoline powered car is, and I'm saying a fraction, like 1%, less than 1%.
Yeah,
I haven't seen
was
the
gonna say,
numbers.
I think it's like 99% less emissions than a gasoline powered internal combustion engine.
Yeah, and so I just want to keep that in mind. But imagine that, you know, going down to a fraction of what we are today with something like this. Now,
Yeah.
I've seen some unique stuff. One of the unique things was the way they where they store the hydrogen tanks, and apparently the engine is upside down.
Is it? I missed
Yeah.
that.
Oh, I thought I was gonna wait for you to tell.
Wow, you
Yeah.
picked up on that. I must have missed that. That's cool. That's interesting. Is that maybe how they're going to reduce how they're going to reduce backfire?
I don't know, but I was doing my research,
Yeah.
and I was looking at this stuff. So the engine is upside down, which a lot of people complained about, but they've done some really cool things about making it accessible. So the stuff that you would normally get at the top is right at the bottom, so it's easy to have access to. And normally, with the types of fuel cells they have to do, they would have to make a longer wheelbase, and they don't want to do that because of performance and whatnot. So what they've done is they flip the engine upside down and then tuck the two fuel cells right along where the engine is. The fuel cells, the fuel tanks for the hydrogen, and that allows it to be, I guess, compact with the engine, because that's why they flipped it over, is to make space for those hydrogen tanks.
Does it show where they store the hydrogen tanks themselves? Like, does it show a skeleton or
I'll find something on that. Sorry, I should have pulled that video up. I was looking at it because it's really cool on some of the stuff they're doing. So I'll ask you a couple of questions. So, you know, where are we from a hydrogen infrastructure? We keep talking about, oh, this is great, look at all this future technology, but when are we going to see hydrogen fill up stations in most towns?
We're nowhere. We're nowhere. We're actually going backwards with hydrogen, and I think we've touched on this a couple of times. But based on what I've seen in my research, I think there's in Canada 1, maybe 2 fuel cell, and I think they're in BC. I don't even think there's one in Ontario. I could be wrong. So I think Europe might be further along than North America when it comes to hydrogen, when it comes to the hydrogen infrastructure. But the cool thing is that current infrastructure can be retooled or redesigned to be used to transport hydrogen. For example, the natural gas pipelines that can be retooled or redesigned to carry hydrogen, so, or to transport hydrogen. So, but we're a long ways away from a proper infrastructure, and there needs to be someone that gets behind this. And I was actually just I think you and I maybe touched on this, but there was a sale of 20 gas stations, and I figured, oh, that's great to buy those and convert those to hydrogen fueling stations. But again, there's no real cars that demand it right now, except for, I think, Toyota still has one, and I believe BMW has one on the road. I could be wrong, but I think that's it for now as far as fuel cell technology.
Yeah, I'm not 100%. I know Toyota's got one. I know another company took one off.
Hyundai has one now. Yeah.
There you go.
Yeah.
And again, it's hard to sell only because there's not enough fueling stations around.
Well, and this gets into the problem still that we have. So the range isn't there yet. So the efficiency isn't there. The cost is super high. I think we did an episode where we looked at how much it costs to fill up one of those, and I think it was like $200, and you only get, I think, 200 miles out of it or 300 miles out of it, and that was based on the Toyota. So, but it's good to see that all of these manufacturers, car manufacturers, are putting their money behind hydrogen, because if we can get to a clean hydrogen production, but even if we're not clean hydrogen, it's still way better than mining lithium and those batteries, because those batteries are hard to recycle as well. So the cool thing, and what you've talked about, the cool thing about Ferrari's technology is that it's essentially a car that runs on hydrogen, as opposed to a battery recharging hydrogen fuel cell car, if that makes sense. So,
yeah, I put a video on here that we're watching that's kind of describing the engine. If people are keep going.
Yeah. And so, again, not that I'm saying that EVs are bad, just the current technology. The current battery technology for EVs is horrible, and the way that they produce it, the way that they can't be recycled very easily, like there's just so many things. And if we can just, if we can just produce cars with a similar engine to gasoline burning engines, all we need to do is solve the storage problem. And obviously,
like our grid and whatnot cannot currently sustain us moving into 100% EVs. Never mind, there's no secondhand market, because currently the batteries aren't recyclable or reusable. Who wants to buy a 5-year-old Tesla when you're not sure where the batteries are in their life cycle, and that's 70% of cost of the vehicle. The tires wear faster because they're heavier. There's all these things. So, which I not necessarily saying they're bad. We're just learning these things as life goes on and saying, okay, well, and as you say, the lithium and the issues with the battery process and stuff, there's a lot of it. Apparently it's a 10-year environmental impact. So we have to really start thinking about what's the next step. And hydrogen, one, is apparently the most common element on the planet, and most abundant, most common, and we can get it anywhere. And the result of this is water, which when we talk about a electric fuel cell based car, we're talking about zero emissions, and pretty close to zero emissions if we're talking about a good internal combustion hydrogen vehicle. And being able, either fuel cell wise or internal combustion wise, being able to pull up the tank. The benefits are you can refuel within 5 minutes. As far as costing goes, while I was researching for this video, I found some saying that it's about twice as much. This person was filling up their tank, and it was $100, and a regular tank was $45. But at the same time, they got $15,000 of free fuel for the first 3 years, so it didn't cost them anything. And they were, the distance isn't quite there, but it's not too bad. It's 200 to 300 miles a tank.
Yeah, exactly. Yeah. But, and that's where we're going to have to get in order for an engine without a battery, for a car without a battery, in order for that to be viable, we need to increase that range. And we've covered some technologies previously that could potentially do that, like storing hydrogen high pressure at room temperature. That's key. But yeah, there's a lot of we're close. But one of the biggest challenges is the lack of infrastructure. It's not there. But the thing is you could essentially build a hydrogen generator for your house out of parts, and create your own hydrogen and fuel up your own car when you get home. That is an option, which is cool. That's just something I thought of off the top of my head, because using electrolysis, you can generate your own hydrogen. So you could essentially equip homes with hydrogen generators.
Yeah, and that's kind of what I was talking about ages ago, right? Like I keep saying, I
Yeah.
think a future where your your house actually makes hydrogen from all the excess electricity, solar, whatever, what's going on to fill up your car or whatever, so that and fill up your internal tank. So when the sun's not shining or whatever, you've got a potential hydrogen generator that actually powers
Mhm.
the home and other things. And you're like, okay, well, this is an interesting future.
Yeah.
Um,
And
but
there's even other technology for storage of that, as opposed to storing it as hydrogen. If you wanted, there's like this ground storage that you can do instead of using obviously lithium-ion batteries to store that additional energy too.
yeah, and then we talked about sulfur selenium batteries. We talked
Yeah.
about a few other types of batteries. I'm drawing a blank on silicon based
Silicon,
batteries.
salt. I think there was a sodium based.
And so we're interesting. There's a few new technologies coming along and seeing this stuff. You're right that we're on early stages, but 10 years ago we didn't have much of the way of an EV infrastructure at all, and now the
Mhm.
malls are full. And so how long does it take to say, okay, let's just put some of these refilling stations in every mall? And you
Yeah.
start to see again a real estate grab, or like you
Well,
say, got these gasoline infrastructures where you just take
mhm.
over something, assuming like we don't know what the protocols are. And I think what's it take to really put in the storage tanks for these things? How much does it cost would set up a fueling station?
Yeah. Well, the thing is too, like I know the reason they have these recharge or these charging stations is because it takes so long to recharge, right? If we're talking hydrogen, it takes minutes to like it's obviously longer than filling up your tank with gas, but it right now it takes minutes. So it'd be interesting to see now that we have these individual charging infrastructures, what is it going to look like once hydrogen becomes more mainstream, right? Are we just going to have you plug it in and you have this machine that actually generates the hydrogen as it's pumping it into your car as opposed to storing it into a tank?
Maybe in the far future, I just
Yeah.
don't see that generation on demand being so close.
No.
So I think that you'd have to store it on in tanks just because the creation process is slower. And we're going to talk a little bit about that in a future article today. Um, are we going to see a entirely new vehicle architecture or a whole new line of hydrogen powered vehicles from Ferrari?
So yeah, yeah. Like you said, we um so they'll like you said, like it's a longer wheelbase. I think you were talking about, or larger vehicle. So they're going to have to redesign their vehicle architectures. They're going to have large, more bulbous body styling to fit the hydrogen tanks. Rear to mid front engine layouts may become more difficult because of those tanks. So it all comes down to the tanks, right? Cabin space may be reduced. The weight, again, you have to come into weight balance. The other thing is the thing that you don't have to really consider, maybe a little bit, is exhaust, because now there's no CO2 coming out of the exhaust. So there might be some innovation as far as exhaust layouts that you could do. Um, but yeah, there's the storage is what clashes with form and function for any kind of especially a supercar like Ferrari.
And that's why they were dealing with the upside down engine and the tanks and stuff. So which is
Yeah.
interesting. Um, they sorry, I lost my train of thought when you were mentioning this. It's a beautiful looking vehicle. When do we think we're going to see them on the road?
Yeah. It all depends. I would say 5 to 7 years. Because yeah, I would say um a reasonable estimate would see first production maybe 2028 to 2030. If only if Ferrari makes this a priority, in my opinion. And that's going to be an initial limited run, which would be like maybe 100 cars, right? Um, but then wider adoption could happen, I think, in the 2030s. If the hydrogen infrastructure expands properly.
Yeah, and that's the next thing. you know, it's not necessarily under this Ferrari engine, but it's when are our governments going to start embracing
Yeah,
a hydrogen future versus a basic EV future,
yeah,
and start incentivizing these projects, because it's got to be the right combination of demand for the hydrogen vehicles, the vehicles being available, and then demand for the fueling stations. Because if there's a private investment, we're not going to build a fueling station. There's only 10 cars in the
no,
GTA.
yeah,
You know, I got to put $10 million into building this safe, large storage tank place where I can pump all this stuff, this
yeah,
filling station, and I'll never get my money back. Why would I do that?
yeah.
So there has to be a long
We
term.
got the we got the chicken and egg problem right now.
Yeah, and you know, it has to work itself out. Again, like we had the electric cars without any chargers anywhere, so
Yeah,
it starts somewhere.
yeah.
Um, and now we've got
Well,
them at.
the thing was you could charge it at home. So right
No, I
now you
know,
can't refuel. Yeah, yeah,
but that's my point, is that it started with, okay, buy my car and I'll do something at home, and maybe that'll be the case. Is okay, you just buy these whatever, and you have a
yeah.
little filling thing at home in your garage, because you could just go down to your local thing and buy a tank.
Mhm.
I don't know. We'll have to see.
Yeah. Like a propane tank kind of thing.
Yeah, exactly. That's what, you know,
Who knows?
or have a guy come by and fill up. If you have a house, you could have one of those big propane tanks. Just have a guy come and fill up your hydrogen tank that fills up.
Yeah.
He, drives around the neighborhood.
Oh
That
my
might,
God! Like what's the heating oil that they used to do
yeah,
back in the day? Yeah, yeah.
yeah.
We can
Why
go
not?
back to that for now.
So if that's what it takes to make it available, but I think
Yeah,
this is really cool technology. It's great to see, companies like Ferrari embrace this. We talked about Toyota. They've been saying EVs aren't the future. We've got that ammonia engine, we've got our hydrogen engine, we've got these things, and we're working. And we last time we talked about the world record set for trains with hydrogen.
yeah, yeah. But that's fuel cell. So that's with a battery, right? But still,
But it's still
still hydrogen.
hydrogen technology, and
Yeah,
it's
still
just
hydrogen
kind
technology.
of, yeah, we're just like, it's
Yeah,
great to see us moving in this environmentally direction, because I mean, I everything we can do to stop poisoning the planet, I'm all
yeah,
in.
for sure. Yeah.
Any last words on this one before we jump on?
No, I'm excited for this one. So I'm excited to see what others and there'll be a cool one that we'll cover with Porsche that they've designed as well. So we'll cover that one later.
So this next one, the secret tweak to Schrödinger's cat equation could unite Einstein's relativity and quantum mechanics. So
I thought of you when I read this.
yeah,
You're like, oh, magic! It's
yeah.
magic. It's hocus pocus. But this could potentially link or eliminate that, or at least help to bridge that gap. So, first off, the Schrödinger cat paradox illustrates how quantum superpositions don't seem to apply at larger scales. So, the authors of this article have added new terms to cause spontaneous collapse, and I put that in quotes, from quantum to classical states. So what this does is it introduces a transition between quantum and classical physics that aligns with what we observe in the real world. Larger systems like cats, and even like the whole universe, they all appear classical. Quantum only applies when you get down to the atomic level, kind of thing. So the modifications that they're proposing have little effect on small quantum systems, but it induces a rapid collapse in larger objects. So it allows both quantum and classical physics to coexist. And if validated, the Schrödinger tweaks could open doors to finally unifying quantum mechanics and general relativity in an intriguing concept. But it requires, obviously, like anything that's changing and like any changes, it requires rigorous scrutiny. So there's going to be a lot of challenges. Testing the predictions will be challenging. In order to test them, we may need some creative new experiments to probe that transition, the quantum classical transitions. And obviously, we're going to need a lot of collaborations here with a lot of smart people way smarter than me. Not that I'm very smart. Revolutionary ideas like this are obviously going to meet skepticism, but there's always changes, and there's always going to be skepticism with any kind of changes that kind of get introduced, especially something as so well known as Schrödinger's cat. So, it'll be interesting to see.
So I like to quote this article here. So such effects are stronger on larger systems. Crucially, these modifications have little impact on a microscopic quantum system such as atoms and molecules, but allow larger systems like the universe itself to collapse at frequent intervals, giving them definite values that fit within our observations of the cosmos. So when we're talking about the universe collapsing, are we talking about like it's collapsing on a regular basis, or are we talking about something like the Big Bang?
Based on what I've read, I think we're talking more about the Big Bang. I don't think we need to worry about it collapsing on itself. But I don't know. I don't know really. Because again, we're talking a theoretical change. We're talking quantum again, which is also theoretical for the most part. But I think it's more talking about the Big Bang than an actual collapse. But it also says spontaneous collapse occurs frequently. So, yeah, there's a lot to digest in this article for sure.
Absolutely. So this is like just reading this is, very interesting. Instead they pose that each system state undergoes spontaneous collapse at regular intervals, leading to acquisition of defined values of some of their attributes. That could mean, almost anything. The new model may explain why our universe space-time geometry doesn't exist in a superposition of states and obeys the classical equations of Einstein's relativity. So Einstein always had a problem with, how can observing something affect the state of it?
Yeah. Well, yeah, exactly. So I guess we should talk about how the tweaking will allow the objects to be in two states at once on the quantum level, but not for larger objects like cats or people. So the standard Schrödinger equation, that only applies to quantum mechanics, and it applies evenly across all scales. But it predicts that cats can be dead and alive simultaneously, just like subatomic particles can. But we never actually observe such superpositions at human scale, right? So the modifications are trying to account for this transition. And then the new terms added cause the mathematical, they were added because the mathematical behavior to change based on the scale of the system. So for tiny quantum systems, the new terms have negligible effect. But for larger objects, the modifications dominate and cause superpositions to rapidly collapse in a definitive state. So their hypothesis is that self-interactions in large complex systems induce this mathematical transition from quantum to classical. So in essence, it's imposing scale-dependent effects that emerge from the underlying math. So it's again, we're talking theoretical, and we're talking really, really advanced and complex math, if that makes sense.
Yeah, and so I have questions.
I'll try to answer them.
If this turns out to be true, does this mean everything is ultimately based on quantum principles rather than classical physics?
Yes. So this is I'm so glad you asked this
or in
question.
layman's terms, if this turns out to be true, is the universe based on magic rather than real science?
I knew so yes. And again, this is based on my understanding and my research. So if the proposed modifications are correct, it would strongly suggest that quantum principles are fundamental across all scales. So the modifications introduce quantum collapse dynamics, even in large-scale systems like the universe itself, which implies that quantum effects are universal. Classical physics would emerge as an approximation of quantum mechanics for large complex systems, according to this perspective. So rather than classical physics being the underlying reality, it would be more of an effect that emerges from the quantum realm under certain conditions. So the quantum to classical transition introduced by these equations means classical physics is no longer entirely separate. So, but again, and the cool thing about this is it does align with growing view among physics that quantum mechanics is the foundational framework that applies to all sizes. So, again, there could be other interpretations of this, but this research direction definitely points towards a universal quantum principle rather than classical physics being fundamental. Like flip the world on its side, flip everything on its end, because quantum mechanics is the fundamental mechanics or physics of everything, potentially.
Yeah, so we sit back and we think about this for a second. So we've got quantum computers able to analyze any particular thing, and say climate, the world, war, politics, whatever. You can throw it at all these things. If observation affects the future, once we start observing things at a quantum level, are we not making the future into what we want it to believe?
Oh, you're getting meta on me now. I don't know. Could
just
we
by
get
observing it, because does it
Yeah.
not make it happen by programming a computer to do this
Or-
analysis to show that the world is going to be, I don't know, let's just say pollution free in 2030, and projecting it out there and say this is, will that actually make that happen?
Well, I'll pose a question back to you. If observing it, do we change the outcome then? Would if and this is we're getting really quantum here, but maybe if we observe it and the world was going to be pollution free and we observe it and now the world's not going to be pollution free.
Yeah, maybe. I based on everything we're saying, that's not how it works. It works is that what you observe first off is what happens, is what it is. And we have to sit back and say, by observing, you've made that multiverse, that thread, this reality exists. These are the types of things that the multiverse is based on. You open the box, the cat is dead, that's one track. You open the box, cat's alive, that's another track.
Yeah.
So by using quantum computers, by using the science, by predicting a future that is this way or analyzing it this way, are we actually going to make these things happen? Does this go down to a level of maybe, and now hear me out here for a second, maybe the people who wrote The Secret and Willing Thing and Mindfulness and bringing all these things and mentally bringing these things into your life had something?
Yeah. I potentially. It reminds me of a movie with Ben Affleck where the guy is a reverse engineering and he reverse engineers this thing, and that's essentially, I can't remember the name of it, but that's essentially what we're talking about here when we're talking about observing, like when we observe it, right? So who knows? This is again really cool. Disrupting physics and quantum. Always love disrupting, so really interesting.
Yeah, that was an interesting movie. I can't remember what it was called, but yeah, they had the crossword puzzle filled out under the bird's cage, and he left clues for himself everywhere, which was interesting. But yeah, once you start observing a future, are you making that happen? Are we manifesting it by our thoughts, our visions, our will? Or is this all hokum? I really
You're
to see
always
where.
gonna think it's all hokum. You know what though? It could be hokum, and because it's still all theoretical, right? Sum of all fears. Nope. I can't remember. Anyways.
Yeah, I may look it up
Yeah, we'll find it
when we're
later.
talking about the next one here. But before we get into the next one, you were talking about the supercar. Have you it's out now.
Oh, the Gemera. I love
Yeah.
this.
So
This is if I become a billionaire, this is my car.
it's a beautiful, like it's got 8 cup holders.
Yeah, it's got 8 cup holders. It's got a floating compass, and it's a 4-seater. Like, it's practical. 4-seater.
You say practical. I mean, I don't know what the price tag is on this. Do you know?
3. I think it's 3 mil.
3 mil? I thought it was
I
2,
could be
but
wrong,
yeah,
but
3 mil. But they're talking about, the reason there's 8 cup holders there's only 2 doors, but they allow access to the
yeah.
front and the back. They're so big, and they got pretty big storage there. But there's one for each person. There's a cold one and a hot one.
Oh, okay. I didn't know that. That's cool.
Yeah. So you're talking about some pretty high-end stuff here, and we talked about the supercar and their new electric engine. I don't know, a few months ago.
What? We'll cover the Koenigsegg engine in one, because I love that. So we'll cover
we did already.
The Koenigsegg EV engine.
Holy
geez. I need a history of all the topics, because we've gone through so many topics.
I know that I actually made a spreadsheet for that purpose.
Oh, yeah, I saw that. No, you did it at the top of our track. Oh, but only for the last 20 so episodes. Anyways.
No, anyway, there's a link to a spreadsheet that has all the episodes. So I'm just anyway, I just wanted to pop this in because it's out now. We can go back and maybe talk about it. But yeah, we did one on their electric engine and what was happening a while ago. So it was early on. Oh. All right, so let's jump to this next one where we're talking about hydrogen.
Yeah, back to hydrogen. And so all the big oil people are going to love this one because it still utilizes oil. So research, what they've done is they've discovered that spraying oil water emulsions produces hydrogen gas through contact electrification at the droplet interface. So the oil helps to extract electrons from the water, improving charge separation compared to pure water droplets. The thing is the charge separation promotes the generation of hydrogen from the water. And so adding surfactants to disrupt the oil-water interfaces suppressed hydrogen formation, which confirmed the mechanism. So the thing is the hydrogen produced could enable direct utilization of water as a clean fuel source. Now, the technique also may allow upcycling wastewater from oil production into hydrogen gas. So this could help us to get the oil on board to help us to transition to hydrogen as a future fuel.
So that's what you think the strategy is all about, is getting big oil on board?
I think so. Don't you think? You don't think big oil's been trying to suppress EVs and other tech that doesn't use oil?
I'm not suggesting that they want continue to dominate the market. I'm just not sure that this is, they're behind this.
No, I think they are. Like, I think they're lobbying to keep dirty oil as long as we can as the dominant fuel source.
So let me ask a question here, and maybe I'm jumping to the end part. If we had this technology working now, and we'll get to whether we can get it working, would have this helped to clean up New Orleans and after the oil spill? The Gulf of Mexico there, the water?
Potentially. Do we want to get into how it actually works, and maybe that'll help?
Yeah, because I'm just saying here, okay, we'll get in. How does it actually separate? Does the presence of oil separate charge and water droplets? How does that work?
So at the interface between the oil and water droplets, I don't know if you have a video of it. I don't know if they have a video, but So the oil helps extract electrons from the water phase. So the oil has a greater affinity for electrons than water does. So the electrons in the water molecules get pulled towards the oil-water boundary, which leaves the water phase relatively more positively charged, while the oil becomes more negatively charged. So the opposite charges accumulate on either side of the interface, creating charge separation between oil and water phases. So the now electron deficient water can undergo reactions at its surface, like ionizing groups into hydrogen plus ions and free electrons. The free electrons can then participate in reduction reactions to generate hydrogen gas from the protons in the water. So essentially, the oil helps pull electrons away from the bulk water, inducing charge polarization at the oil-water interface. And the presence of oil in the surface is key to amplifying the charge separation. So the oil acts as kind of an electron acceptor that promotes charge polarization and electrochemical hydrogen production at the interactive oil-water boundaries.
So there wasn't a video talking about this that I could see, but there's a lot of images in the white paper.
Yeah.
So because it's pretty dense material, so I'm trying to show people the difference between regular and when they hexadane water and hexadane SDS water systems.
Yeah. Well, we can get into the because your question was about helping with the oil spills, but essentially, like, there's a potential for an alternate way to upcycle or treat oily wastewater, right? And that could potentially that I don't know if that would help clean up, but we could potentially generate hydrogen from an oil spill.
Yeah, so the reason I asked it is because we're reading the article and it was saying that the water molecules and the oil molecules are of different sizes, so they're easily separable. So once you go through this process, that's why I was wondering, okay, if we take this water, we just, all right, we're going to use all this and we're going to run it through this process. Are we going to be able to separate the water from the oil and end up with a better quality of water or not?
So potentially.
Let me ask a different question then.
Yeah.
Okay, so we produce hydrogen with this,
Yeah.
and we burn the hydrogen. What's the waste? Is it just water, or is it water plus whatever else? Is there oil, and as a result, carbon?
Yeah. So the waste. Yeah. So I guess sorry about that.
That's okay. I'm throwing these at you
I'm not
because
too sure. So let me put it that way. So the hydrogen production essentially is so hold on. It does produce some sort of wastewater, but the thing is that, like, petrochemical, oil refining, and other processes, they produce wastewater, which contains both oil and water. So I don't know the reason why I'm hesitating is because I'm not too sure what the end product is from an oil perspective and what could be done with it. I didn't catch that in the article.
okay, and it looks like they're using hexadane mostly for this, or hexadecane. Sorry.
Okay.
Um,
Yeah, this is a really this was a really complex article for me to go through. It took me a lot of time to kind of pull out the relevant information that would be good to talk about on this, but it's really cool technology.
Yeah, I like the concept in that we're trying different things, like, like adding chromium, I think it was, to the titanium bits to increase the longevity and the actual creation of hydrogen, but also to reduce the cost by 90%.
Yeah. So there is a waste oil water mixture that gets discharged after the hydrogen extraction. but it doesn't talk about, so there could be some negative environmental impact. So the oil residues and the other components would have to be obviously treated properly. If they have large installations, it could impact coastal habitat. So we'd have to figure out a way to filter that, maybe, or figure out how to use the waste from it, the discharge.
Yeah, and specifically, it does say that this looks like you'd have to upscale this, but traditional wastewater treatment technology always results in significant carbon emissions. This study indicates that it's possible to realize the upcycling of oil-containing wastewater by spraying an oil-water emulsion to generate H2 from water, which could transform the oily wastewater treatment process into a viable carbon sequestration pathway. So,
Yeah.
sounds like we could use this to
I think
clean
we
up some
could
of this
use it
stuff.
to generate hydrogen to continue to generate the wastewater treatment process, if that makes sense, like a cycle.
Absolutely. So
Yeah.
this is it's really cool, but we really don't know what the impact is. Like
Yeah.
from spraying the oil with water long term, and separating it afterwards and all that kind of stuff. Was it hexa? Was that that's the oil that works the best?
I don't know. I didn't. What I tried to do was, because this was such
I know.
a complex. I just tried to pull out the high level stuff. So I'm not sure.
Yeah, I know it was pretty dense. I was, going through and it's like, whoa,
Yeah.
that's why I was like, all right. So how competitive could the cost of hydrogen production be compared to existing methods? Can we,
So
once we can drop the price of hydrogen,
yeah,
and if we can say, all right, what's the price of gas at the pump right now? a dollar $1.68.
dollar
Okay,
66. Yeah,
$1.66. And what percentage of that is tax?
30, 25. I can't
Yeah, I think
remember.
it's more than that. But anyway, it's fine.
Yeah.
If we did this hydrogen, which was carbon neutral, and they remove that as a tax because we want to encourage this,
Mhm.
and we can reduce the cost of
Yeah,
creating it with something like this, can we get the cost down to being affordable? Can we get this down to something consumers can afford to actually start driving around again?
absolutely. But so the couple things to think about. So first off, the droplet technique, it could have significantly lower capital costs because it requires a relatively simple spray equipment versus large reformers or electrolyzers, right? So that improves scalability. Operating costs may be lower because you won't need extensive gas purifications or compressed hydrogen storage or transportation. However, though, the efficiency and hydrogen production rate per unit of oil water volume processed, that needs to be determined and possibly optimized, which will affect operating costs. So the main feedstocks of water and some added oil are relatively low cost and abundant, right? So which provides a cost advantage. But again, material durability, maintenance, and replacement are also a factor. So there's still uncertainty, but it seems like if they can get this right, operationally it's simple. There's a lot of accessible. Those are great cost advantage. So they'd have to work on the production volume, efficiency, and system lifespan in order for it to be proven. But I think, I think this is a great potential option. And I think we're going to need a lot of different options and then figure out which one scales the best. Maybe there's different options for different areas in the world. And then that comes down to how do we transport that hydrogen and different things like that. But yeah.
So we're always looking at hydrogen. It seems like we almost have a hydrogen one, at least, well, two in this
Yeah.
live episode almost every week. This is becoming awesome, but do I sit back and say, am I concerned about our clean water sources over time because we're going to start tapping into hydrogen everywhere, or is it actually not a concern?
Sorry, repeat that. You cut out on me there.
Sorry, are we, is it going to start tapping into our clean water reserves? This has always been Canada's got a lot of fresh water, clean water, and
No, because we can use wastewater in this
okay,
process. Yeah. Yeah. That was a
great.
simple answer.
Yeah, I just wanted to, water is going to be, it is already, bottled water is expensive and
Yeah,
whatnot. And, clean water seems to be something that we struggle with as a world. And
yeah,
we're of abundance of it here in Canada. And I'm concerned that, as soon as we start using that for things like this, we end up with
yeah.
whatever the output
Well,
is.
yeah, but that's what I like about this is because you can use wastewater with this. So we could potentially be upcycling water that potentially could be going back into the environment and harming the environment as is, and using this to produce hydrogen instead of using clean water.
Any final words on this one?
No, I do have a thought, and this is me going down a rabbit hole. Are Because of all the hydrogen stuff we covered, obviously we're a little biased towards it, or at least I am, and you are too, though. Are we? Do we see something, or are we oversaturated in that we have this higher potential positive hydrogen taking over because of all these articles? Like, are we blind to what's actually happening, or?
Well, that's a good question. And,
Yeah,
we have over 40 people watching. If anybody thinks that there's another solution out there that we should be looking at, but we look at the other stuff. Like we've already talked about 3 or 4 different battery technologies. We've talked about the ammonia engine from Toyota.
yeah,
If there's other types of engines other than EVs, because we were looking at those, the Cronenberg EV was great.
yeah,
And new technologies in that area. Happy to take a look at any other alternatives that seem to be on the horizon. So
absolutely.
I don't think we're blinded to it. It's just that there doesn't seem to be as much out there right now, and
Yeah,
uh, we might be in a what you would call a somewhat of an echo chamber because we're seeing all this stuff. But
yeah,
um, at the same time, if you're not paying attention, you're in the EV echo chamber. So
yeah,
just
exactly.
because it's we're told it's better and it's great and all that stuff, which it is on many levels.
Yeah, as long as we can get the clean hydrogen, we're golden. So
All right, so what do you got going on, John?
I don't have much. The only thing coming up is on May 30th. I've got the Sunrise Social, which we talked about on the weekend on May 27th. So there's
Sorry, that's not true. It's May 30th is Startup Drinks TO, and May 31st is the Summer Bash from, you called it the Sunrise Social, but I think it's the Summer Bash from the National Crowdfunding Association.
Oh no, sorry, I was talking about the non-tech related Sunrise Social
Oh,
yoga.
the morning one. Yes, you did. Is that May 30th?
No, May 27th.
May 27th. Great. You
Oh,
said May
and by
30th.
the way, I don't think that date is right. I think that's that's what it was last year, May 31st. I don't think it's been scheduled yet. The NACO one.
Oh, the NCFA. Okay, I'll reach out to my
Yeah.
contact there. And
Yeah. Yeah, I'd love to go to that kick. I love that. That was a great event.
yeah, the National Crowdfunding Association, Craig Asano and Lauren Litton, who work hard on that, and there's a couple other people. Forgive me for not remembering everybody's names, but they're a great team of people, and it's always a good event. Yeah, and if it's not May 31st, if it's a different day, I'll probably go.
Yeah.
So I'll reach out and talk to them because it's always a good time. And if it's later, I'd like to see if we can give a ticket away at our May 30th Startup Drinks event so we can promote it a little bit. So
Absolutely. Yeah.
and if people want to know more about how to get funded, government funding, grant programs, that kind of stuff, where do they go?
Yeah, reach out to me on LinkedIn, John Irwin, JONOH Irwin, IRWIN. Pretty easy to find. Yeah, feel free, reach out to me if you have any questions on non-dilutive funding.
And I mentioned startupdrinksto.com. We do startup investor drinks, open bar, pizza. You get up to 20-second pitch. You can pay for more, but there's investors and founders and mentors and funding experts. It's a great time. We do it once a month, so definitely come out and see us there.
Yeah.
If you're struggling with your business, go to startupcoach.ca. See if I can help you get unstuck. But I'm about to launch a course in June about productizing your knowledge. So if you're a knowledge worker, a subject matter expert, or a technical guru, and you're trying to figure out how to turn your knowledge into a course, a book, or a coaching program, I'm launching a course to teach you how to do it. It's the clearest method to get the knowledge from your head into a course, a book, or program. And I'm launching that in June. The first cohort will be 50% off. I've already teach some individuals, and the feedback has been great. So if you want that, go to startupcoach.ca, reach out to me. I'll put you on the email list, and we'll get you started. It's a really fun program. I've got all the templates. It really, within a very short period of time, you can take your knowledge and turn it around in a week or 2 weeks, depending how quickly you want to work on it.
Love it.
All right, that's it, everyone. Thank you very much for joining us. We are talking about moving these to Thursday mornings on a regular basis, so stay in touch for that, and hopefully like and subscribe on wherever you are. Appreciate everyone.
Thanks, guys.
Talk to you soon, John.
Bye, Craig.